SpaceX Dragon spacecraft. Dragon 2 is a class of partially reusable spacecraft developed and manufactured by American aerospace manufacturer SpaceX, primarily for flights to the International Space Station (ISS). There are two variants: Crew Dragon, a spacecraft capable of ferrying up to 7 crew, and Cargo Dragon, an updated replacement for the original Dragon 1. The spacecraft consists of a reusable space capsule and an expendable trunk module. The spacecraft launches atop a Falcon 9 Block 5 rocket, and the capsule returns to Earth via splashdown. 4 operational Dragon 2 spacecraft have been manufactured. Cargo Dragon supplies cargo to the ISS under a Commercial Resupply Services-2 contract with NASA. The first flight of Dragon 2 in a cargo configuration launched in December 2020. It shares this duty with Northrop Grumman Innovation Systems' Cygnus spacecraft, and Sierra Nevada Corporation's Dream Chaser spacecraft is expected to join them no earlier than June 2022. As of 2021, Crew Dragon is the only U.S. human-rated orbital transport spacecraft, the only reusable crewed spacecraft, and the only reusable cargo spacecraft currently in operation. Its primary role is to transport crews to and from the ISS under NASA's Commercial Crew program, succeeding the Crew orbital transportation capabilities of the Space Shuttle, which retired from service in 2011. No earlier than June 2022 will be joined by Boeing Starliner in this role. Crew Dragon is also used for non-docking orbital space tourism, and is expected to be used to shuttle tourists to and from Axiom Space's planned space station. Dragon is made up of a pressurized capsule that will carry pressurized cargo on this mission, and an unpressurized trunk that houses its solar panels and can be used to carry unpressurized cargo. Dragon represents the best of cutting-edge technology. SpaceX developed Dragon from a blank sheet to its first mission in just over 4 years. In December 2010, Dragon became the first privately developed spacecraft to return safely from orbit, a feat previously achieved by just 3 nations: the United States, Russia, and China. Dragon is 4.4 meters, 14.4 feet, tall and 3.66 meters, 12 feet, in diameter. The trunk is 2.8 meters, 9.2 feet, tall and 3.66 meters, 12 feet, wide. With the solar panels fully extended, the vehicle measures 16.5 meters, 54 feet, wide. Although this demonstration mission carries only cargo, Dragon was designed from the outset with crew carrying capability in mind. SpaceX is in the process of developing necessary systems for transporting crew, such as seating, a launch escape system, and environmental control and life support systems. Dragon has the most powerful heat shield in the world. Designed in cooperation with NASA, it is made of a material called Pica-X, a high-performance variant on NASA's original phenolic impregnated carbon ablator Pica. Dragon is capable of carrying over 3,310 kilograms, split between pressurized cargo inside the capsule and unpressurized cargo carried in the trunk. While this mission is carrying cargo only, future Dragon missions will be capable of carrying 7 passengers in the crew configuration, designed for lift during re-entry for precise landing and low G-forces. Key components: Draco thrusters. 18 Draco thrusters were used for orbital maneuvering and attitude control, providing system redundancy. Powered by nitrogen tetroxide/monomethylhydrazine, NTO/MMH. Storable propellants: 90 pounds, 400 N. Thrust used for on-orbit maneuvering, deorbit burns, and re-entry attitude. Power: 2 solar array wings on the trunk, 8 panels total. Avionics: 2 fault-tolerant avionics system with extensive heritage. Communications: communications between Dragon and the ISS are provided by COTS UHF Communications Unit, Cuckoo. Cuckoo was delivered to the space station on SDS-129. The ISS crew commands Dragon using the Crew Command Panel, CCP. The Dragon can also communicate on S-band via either the Tracking and Data Relay System, TDRSS, or ground stations. Environmental control system: astronauts will enter Dragon to remove cargo. The craft provides a habitable cabin with air circulation, fire detection and suppression, lights, pressure control, and pressure and humidity monitoring. Thermal protection system: primary heat shield is made of tiled phenolic impregnated carbon ablator, Pica, fabricated in-house. The back shell is made of SpaceX proprietary ablative material SPAM. Parachutes. Dual-drode parachutes slow and stabilize the craft before three main parachutes bring it to a gentle landing. The Dragon can also land safely with only one drode and one main parachute if needed. Transporting crew. To ensure a rapid transition from cargo to crew, SpaceX has designed the cargo and crew configurations to be nearly identical, with notable exceptions including the need for a crew escape system, the life support system, and onboard controls that allow the crew to take control from the flight computer when needed. This focus on commonality minimizes the design effort and simplifies the human rating process, allowing systems critical to Dragon crew safety and ISS safety to be fully tested on unmanned demonstration flights and cargo resupply missions. Design. Crew Dragon C-204 in the LC-39A Horizontal Integration Facility in December 2018, preparing for the launch of DM-1. Dragon 2 includes the following features. Dragon 2 is partially reusable, potentially resulting in a significant cost reduction. After earlier plans of SpaceX to use new capsules for every crewed flight for NASA 42, both agreed to reuse Crew Dragon capsules for NASA flights. Cargo Dragon can carry 3,307 kg, 7,291 lb to the ISS. Crew Dragon has a capacity of 7 astronauts. Only 4 seats are used for NASA missions. Above the seats, there is a free-screen control panel, a toilet with privacy curtain, and the docking hatch. Ocean landings are accomplished with 4 main parachutes in both variants. The parachute system was fully redesigned from the one used in the prior Dragon capsule, due to the need to deploy the parachutes under a variety of launch abort scenarios. Crew Dragon has 8 side-mounted Super Draco engines, clustered in redundant pairs in 4 engine pods, with each engine able to produce 71 kN, 16,000 lbf, of thrust to be used for launch aborts. Each pod also contains 4 Draco thrusters that can be used for attitude control and orbital maneuvers. The Super Draco engine combustion chamber is printed of Inconel, an alloy of nickel and iron, using a process of direct metal laser sintering. Engines are contained in a protective nacelle to prevent fault propagation if an engine fails. Once in orbit, Dragon 2 is able to autonomously dock to the ISS. Dragon 1 was birthed using the Canadarm2 robotic arm, requiring substantially more involvement from ISS crew. Pilots of Crew Dragon retain the ability to dock the spacecraft using manual controls interfaced with a static tablet-like computer. The spacecraft can be operated in full vacuum, and the crew will wear SpaceX-designed spacesuits to protect them from a rapid cabin depressurization emergency event. Also, the spacecraft will be able to return safely if a leak occurs of up to an equivalent orifice of 6.35 mm, 0.25 in diameter. Propellant and helium pressurant for both launch aborts and on-orbit maneuvering is contained in composite carbon overwrap titanium spherical tanks. A Pika X heat shield protects the capsule during re-entry, while a movable ballast sled allows more precise attitude control of the spacecraft during the atmospheric entry phase of the return to Earth and more accurate control of the landing ellipse. Location 18, a reusable nose cone, protects the vessel and the docking adapter during ascent and re-entry. 18, pivoting on a hinge to enable in-space docking and returning to the covered position for re-entry and future launches. The trunk is the third structural element of the spacecraft, containing solar panels, heat removal radiators, and fins to provide aerodynamic stability during emergency aborts. The previous Cargo Dragon's deployable solar arrays have been eliminated and are now built into the trunk itself. This increases volume space, reduces the number of mechanisms on the vehicle, and further increases reliability. Announced on 29 August 2021 during the CRS-23 launch is a new feature called expendable installed in the Cargo Dragon. Our new Cargo Dragon vehicle is also able to act as a laboratory in the advancement of science and research. We call this capability expendable. It allows some powered payloads to remain on Dragon for experimentation during the duration of the mission. This is especially helpful when there is limited to no space on station for additional science. And it also helps cut down the amount of time the crew has to move payloads in and out of Dragon. For CRS-23, there are 3 expendable payloads launching with the mission, and once docked, a 4th, which is currently already on the space station, will be added to Dragon. For missions not involving docking to ISS or any other spacecraft, and those involving space tourism, the Capsule docking adapter, which is normally used to dock with the International Space Station, can be replaced by a domed plexiglass window allowing 360-degree views out of the spacecraft, providing views of space and the Earth like the cupola module on the ISS to provide interest and make up space left after removal of the docking adapter during flight. The dome's first use was on the Inspiration 4 flight,